Throughout history, humanity has gazed up at the stars with a sense of wonder and longing. The vast distances between us and those twinkling points of light have seemed insurmountable. For centuries we were confined to our own planet, bound by the limits of our technology. But the human spirit is not easily deterred. We dreamed of reaching the stars, of venturing out into the vast cosmic ocean. Science fiction writers gave us glimpses of what might be possible. They envisioned starships that could traverse the galaxy. These stories ignited a spark of hope and ambition in many. Could we one day make these dreams a reality? Today, on the cusp of a new era of space exploration, we glimpse the possibility of turning science fiction into scientific fact. The Alcubierre Warp Drive, once impossible, is now being seriously considered. This idea holds the key to unlocking our interstellar future. Let's explore the fascinating world of warp drive, the challenges ahead, and the possibility that faster-than-light travel may one day be within our grasp. To understand the Alcubierre Warp Drive, we must first delve into Einstein's theory of general relativity. Published in 1915, this theory revolutionized our understanding of gravity. Einstein proposed that gravity is a curvature of space-time caused by mass and energy. Imagine a bowling ball on a trampoline. The ball causes the surface to dip, creating a curvature. Now imagine a marble rolling near the ball. It curves inward toward the heavier object. This is how gravity works according to Einstein. The Earth warps space-time, pulling objects towards its center. The Alcubierre Warp Drive manipulates space-time curvature ingeniously. Instead of traveling through space, it manipulates space itself. Imagine a spacecraft within a warp bubble. The bubble compresses space in front and expands it behind. The spacecraft remains stationary like a surfer on a wave. The warp bubble travels through space, potentially faster than light. Space itself is not limited by the speed of light. By manipulating space-time, the Alcubierre Warp Drive offers a loophole for faster-than-light travel. The concept of warp drive remained firmly in the realm of science fiction until 1994, when a Mexican physicist named Miguel Alcubierre published a groundbreaking paper titled "The Warp Drive Hyper-Fast Travel Within General Relativity." In his paper, Alcubierre proposed a theoretical framework for a warp drive based on Einstein's field equations, the mathematical language of general relativity. Alcubierre's equations demonstrated that it was theoretically possible to create a warp bubble that could transport a spacecraft at arbitrarily high speeds. He envisioned a bubble of space-time that would contract in the direction of travel and expand behind the spacecraft, creating a region of warped space-time where the spacecraft could effectively surf on the wave of compressed space. This groundbreaking work sent ripples of excitement through the scientific community. For the first time, faster-than-light travel was no longer a purely fictional concept. It had a mathematical basis in established physics. Alcubierre's paper opened up a Pandora's box of possibilities, igniting a firestorm of research and speculation into the feasibility of warp drive technology. However, Alcubierre's solution came with a significant caveat: the need for a mysterious and elusive ingredient known as exotic matter. Alcubierre's warp drive concept, while groundbreaking, hinges on the existence of a very peculiar substance, exotic matter. This hypothetical form of matter is theorized to possess negative mass, a concept that defies our everyday understanding of physics. We are accustomed to matter having positive mass. A bowling ball, for example, has positive mass, which is why it resists our attempts to move it, and why it exerts a gravitational pull on objects around it. Exotic matter, on the other hand, is proposed to have negative mass, meaning that it would be repelled by gravity instead of being attracted to it. This bizarre property of exotic matter is crucial to the functioning of the Alcubierre Warp Drive. According to Alcubierre's calculations, a ring of exotic matter would be needed to create the warp bubble around the spacecraft. This ring would generate a region of negative energy density, effectively warping space-time around it and allowing the bubble to move faster than light. The problem? Exotic matter has never been observed in nature, and its existence remains purely theoretical. While some physicists believe that tiny amounts of exotic matter might be created in high-energy environments like black holes or particle accelerators, harnessing and manipulating enough of this elusive substance to create a warp drive remains a daunting challenge. Section 5. Recent developments, bringing warp drive closer to reality. Despite the significant hurdle of exotic matter, The allure of faster-than-light travel has spurred scientists to continue exploring the possibilities of warp drive technology. In recent years, there have been some promising developments that have brought the dream of warp drive a step closer to reality. One significant breakthrough came in 2024, when a team of physicists published a paper in the journal Classical and Quantum Gravity, proposing a modified version of the Alcubierre Warp Drive that might not require exotic matter. Instead of relying on negative mass, this new model suggests that a specific configuration of gravitational fields could be used to create the warp bubble, potentially circumventing the need for exotic matter altogether. Another exciting development is the emergence of sophisticated computer simulations and modeling tools that allow physicists to study the complexities of warp drive in greater detail. The Warp Factory Toolkit, developed by the Advanced Propulsion Laboratory at Applied Physics, is one such example. This open-source toolkit enables researchers to model the unique physics of warp drive, paving the way for a deeper understanding of its potential and limitations. These advancements, while still in their early stages, offer a glimmer of hope that the technological hurdles standing in the way of warp drive might one day be overcome. Section 6. NASA's involvement, exploring the frontiers of spacetime. The tantalizing possibility of warp drive technology has not escaped the attention of NASA, the world's leading space exploration agency. In recent years, NASA scientists have been conducting theoretical research and experiments to investigate the feasibility of warp drive and other advanced propulsion concepts. One prominent figure in NASA's warp drive research is Dr. Harold "Sonny" White, a physicist at the Johnson Space Center. Dr. White has proposed modifications to the Alcubierre Warp Drive model that could potentially reduce the energy requirements, making it more feasible with our current understanding of physics. Dr. White's research, along with the work of other scientists at NASA and around the world, demonstrates the growing interest in warp drive as a potential means of interstellar travel. While significant challenges remain, the fact that a leading scientific institution like NASA is dedicating resources to warp drive research is a testament to its potential to revolutionize space exploration. Section 7. The Accidental Discovery, a Glimmer of Hope. In a serendipitous turn of events, a team of researchers funded by the Defense Advanced Research Projects Agency, or DARPA, stumbled upon a tantalizing discovery in 2022. While working on a project unrelated to warp drive, the team accidentally created a microscopic warp bubble within a Casimir cavity, a specialized experimental setup used to study the quantum effects of vacuum energy. This accidental discovery, although on an infinitesimally small scale, sent shockwaves through the scientific community. It provided the first experimental evidence, albeit indirect, that the manipulation of spacetime necessary for warp drive might be possible. While this discovery is far from a working warp drive, it has injected a surge of excitement and optimism into the field. It suggests that the theoretical underpinnings of warp drive might be more robust than previously thought and has spurred renewed efforts to understand and replicate this phenomenon on a larger scale. Section 8. Conclusion. A future among the stars. The Alcubierre Warp Drive, once a figment of science fiction, is now a tantalizing possibility on the horizon of scientific exploration. While significant challenges remain, including the need for exotic matter or alternative methods of space-time manipulation, the relentless march of scientific progress continues to bring us closer to a future where interstellar travel might become a reality. The accidental discovery of a microscopic warp bubble, the development of sophisticated computer models, and the ongoing research by institutions like NASA all point towards a future where the seemingly insurmountable barriers of space and time might one day be overcome. The pursuit of warp drive technology is a testament to the boundless ingenuity and ambition of the human spirit. It is a reminder that even the most audacious dreams can take flight when grounded in scientific principles and fueled by our unquenchable thirst for exploration and discovery. While the journey to the stars may be long and arduous, the potential rewards are immeasurable, promising to unlock the secrets of the cosmos and usher in a new era of human exploration and understanding.